Right, so a little bit of a strange situation, but it's actually my turn to assume the speaker role. For this next talk, I'll be talking about the use of multi-device imaging to understand laser tissue interactions over time. I'm Emily Winandi. I'm a doctor at the Department of Dermatology at Bispebjerg Hospital and a postdoc with Marit Heddersdal. These are our disclosures. So the 1927 nanometer fractional thulium laser, or the FTL, is commonly used in medical and cosmetic settings to treat pigment disorders, photo damage, and acne scarring. And not infrequently, the device is referred to as a non-ablated device, though few published studies actually take a look at FTL tissue interactions in a relevant in vivo human setting. Now, over the past years, OCT, with its depth penetration of up to 2 millimeters, has emerged as a nice, non-invasive alternative to histology. And more recently, our group in Copenhagen has begun adding line field confocal microscopy to the mix, or LCOCT, to take advantage of the technology's high resolution. So, using these two combined capabilities, we aim to explore the full range of FTL's tissue interactions in an in vivo study. Now, in the study setup, we exposed 8 separate test sites of normal human forearm skin to FTL using 2 different tips, C1 and C5, each with a fixed spot size and density. To improve or to get the full representation of the range of FTL, we tested each area with one of 4 pulse energies, going from 0 millijoules to up to 20. Now, immediately after laser exposure, we used these imaging devices to take a look at MTZ depth, diameter, degree of ablative effects, and stratum corneum involvement. As a second outcome, we also used the imaging tools to evaluate postoperative healing based on filling of the channels and timing of re-epithelialization, starting at 1 hour and going up to 1 week after laser. So what did we find? Well, perhaps unsurprisingly, imaging did show that rising fluences increase MTZ depth and diameter, and also the degree of ablative effects and SC involvement. Further, imaging revealed key differences between the 2 laser tips. So let's begin with C5. At low fluence, OCT showed a discrete focal intraepidermal clefting with a seemingly spared stratum corneum. When we increased the fluence, the thermal effects extended superlaterally towards the skin surface, resulting in frank ablation at the high 20 millijoules pulse energy. Here you can see that effect visualized really nicely in a high-resolution en face image, LCOCT image of the stratum corneum. Corresponding with the OCT findings that I mentioned earlier, you see here images suggesting a relative sparing of the stratum corneum at low fluence and a clear ablative effects at the higher fluence. And taking a look at the same channels depicted in vertical sections, that effect becomes even more clear. Spared stratum corneum at the low fluence and an overt ablation at 20 millijoules. So what about the C1 tip? Well, taking a look at the high fluence at the bottom image, the stratum corneum is pretty clearly disrupted. But it's a little harder to say the same at the 3 millijoule setting on the upper picture on the OCT alone. So on the LCOCT, however, we were able to define discrete microdisruptions in the stratum corneum, even at the low fluence, suggesting a semi-ablative effect that obviously differs from the intraepidermal clefting using the C5 tip. So having characterized the MTZs at their inception, we wanted to see how they evolved over time. And what we learned was that there was almost a top-down filling of the superficial aspect of the MTZs that we were able to detect by 6 hours. And later, we saw complete migration of the epidermal keratinocytes over the ablation defect that occurred by 24 hours. And a week later, the thermal effects were still apparent. We saw MENDs continuing their transit up towards the skin surface, providing a beautiful demonstration of the dynamic healing process. So, to conclude, maybe we shouldn't be calling FTL just a non-ablative laser. Rather, it's capable of producing semi-ablative effects and even frank ablation at higher settings. And secondly, it's important to note that OCT and LCOCT actually have complementary capabilities that are really useful in laser tissue interactions. Thank you for listening.